Hey everybody, this is going to be a quick homework review of day 11, the multi-step experiments for independent events, and this can sometimes be a tricky homework unless you label your dashes and tree diagrams carefully. And so I say hello, and Frodo says hello right here. He's saying hi, he's tired. All right, let's get right to it. So the first page can be done relatively simply as long as you draw tree diagrams. And first one says flip a coin 4 times. So look what I did here. Let me get the draw feature right now. Good, good, good. Erase this. Each of these columns represents a flip of the coin. So the first flip of the coin is right here. The second flip of the coin is this column. Third flip of the coin, and fourth flip of the coin. And yes, you could tell if I did a fifth flip, this would get unmanageable. So tree diagrams are good for few trials. That's what I said in the notes. And this is probably my limit right here, at least. There are 16 options in that last column. So that means my denominator is going to be 16 for this. Okay, so exactly 3 tails in floor flips. So let's just circle the branches that have 3 tails. This branch, heads, tails, tails, tails. That has 3 tails in it. How about tails, heads, tails, tails? That has 3 tails. How about tails, tails, heads, tails? That's a third branch. And then last but not least, tails, 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 heads. I believe those 4 branches out of the 16 have 3 tails. That's it. I'm not even going to make you reduce. I know that's 1/4. At least 3 tails. Well, just by definition, at least means that number or more. So it's 3 tails or 4 tails. We already know that there's 4 branches out of 16 that have 3 tails. 4 means plus. It's from our lesson before. How many of these branches have 4 tails? I'll use a different color. I do believe that the only branch with 4 tails, let's try the highlighter, is tails, 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 tails. That's cool. Maybe I'll do the highlighter from now on. I like that. Ooh, yeah, I learned something new right there. All right, so that's an extra choice. So then that's an extra 1 out of 16. So then there are 5 total branches out of 16. That's my answer for part B. Part C, 2 tails and 2 heads. So let's see here. Can I erase the highlighter? Yes, I can. Oh, that's so cool. So how many branches have 2 tails and 2 heads? So right off the bat, I see heads, heads, tails, tails. I see heads, tails, heads, tails. I see heads, tails, tails, heads. And what else do I see? I see tails, heads, heads, tails. I see tails, heads, tails, heads. I see tails, tails, heads, heads. And I believe that's it right there. How many branches did we create? I love this highlighter. 1, 2, 3, 4, 5, 6 branches. So a total of 6 branches out of the 16 have 2 tails and 2 heads. So cool. All right, let's slide on down. Family has 2 children. Oh, this is an easy tree diagram. So the first child is just a boy or girl. The second child could be boy, girl, boy, girl. So 2 girls. There it is right there. Just 1 branch out of 4. My denominator is 4 for all this because there's 4 things on the last branch. All right, and 2 boys. That's right there. That's another 1 branch out of 4. At least 1 boy. At least means that number or more. So that's either 1 boy or 2 boys. We already know 2 boys. That's 1/4 from just above. 4 means plus. How many of these branches have 1 boy? I'm just going to do circles here. I could either do boy, girl, or I could do girl, boy. That's 2 branches right there. So 2 branches out of 4 plus 1 out of 4. Hey, that's 3/4. Last but not least, 3 boys. Not fooling me, Collodi. Can't have 3 boys. Why? Because you're only having 2 children. All right, that's it for number 2. To do numbers 3 and 4, I would not recommend tree diagrams. I would recommend writing your dashes out. I did notice on some of your homeworks that some just wrote single fraction answers for number 3 and number 4. That's not going to fly because, especially in number 3, you are drawing 3 cards. And when you're drawing 3 cards, you need 3 dashes. So, all hearts. One thing, watch this here. Let me share the screen. Oops, sorry. Let me go up here. Share. How many hearts are there? There are 13 hearts. So let's go back to the homework page. This is what I like about Zoom. You can toggle between screens. And let's go back to our homework page. So that means there are 13 hearts out of 52. Oops, no, I don't want to do that. Let's erase. 13 hearts out of 52 times another 13 hearts out of 52 times another 13 hearts out of 52. King, queen, number card in that order. Without going to each one, there are 4 kings out of 52 times 4 queens out of 52. A number card. I will go to the other sheet for this one. How many number cards are there? There are number cards in each, there are number cards in each suit. Numbers, 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 numbers. 2 through 10. Let's think about this for a second. Do it on my hands. 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 9 cards that have numbers on them. So let's think about that. 9 cards times 4. This is 9. Oops. This is 9, 9, 9, and 9. 9 times 4 is 36 total cards. Let's go back to our sheet and let's fill that in. So then that's times 36 out of 52. In that order. So it's got to be a king first, queen second, number card third, in that order. So we're done with B. C says in any order. The probabilities don't change. So 4 out of 52 for the king times 4 out of 52 for the queen times 36 out of 52 for the number card. Now I need to take these fractions and multiply by the ways to arrange a king, a queen, and a number card. I'll do that quickly. King, queen, number card. Or I could do king, number card, queen. Or I could do queen, king, number card. Or queen, number card, king. Or I could do number card, king, queen. Or I could do number card, queen, king. That's 6 ways. So I'm going to take those 6 ways and multiply them right there. Take the fractions from part B and multiply them by the 6 ways to arrange them. Only one black card. Well, in a card deck, card is either black, which is clubs or spades, or it's red, which is diamonds and hearts. And half of the deck is red, half of the deck is black. So the fractions don't change. 26 out of 52, 26 out of 52, 26 out of 52, multiplication in between. But how many ways can I arrange black, red, red? So I could do black, red, red. I could do red, black, red. And I could also do red, red, black. So I'm going to take those fractions here and I'm going to multiply by the 3 ways to arrange 1 black and 2 red. Notice it doesn't say the black has to be the first card, any order. As a result, E does have an order. Ace is the first card. So there are 4 aces in the deck. So we have 4 to 52. However, does it say only the first card is an ace? No, it says just the first card is an ace. What could be in the next 2 spots? Anything. Anything. It doesn't say ace can't be in the second or third. It just says the first one has to be an ace. So any of the 52 cards in the deck can go in the remaining 2 spots. with multiplication in between. Remember, fundamental counting principle for that. All right, last but not least, number 4, you're drawing 2 M&Ms, and I already set up there's 10 M&Ms total. So yellow, then red. There are 2 yellow, so 2 out of 10 times red, which is 5 out of 10. Both yellow. All right, well, that's 2 out of 10 times 2 out of 10. A blue and a red in that order. So blue first, it's 3 out of 10 times red, which is 5 out of 10. A blue and a red in any order. So the fractions don't differ. That's 3 out of 10 for blue times 5 out of 10 for red. But now times the ways I could arrange blue and red. So blue and then red, or I could do red, then blue. So I'm going to multiply by the 2 ways that I can arrange blue, red, red, blue. Last but not least, at least 1 red. So I kind of set this up. At least means that number or more. So either 1 red or 2 red. So let's start with the 2 red. Red is just 5 out of 10 times 5 out of 10. To get 1 red, that means to get a red, which is 5 out of 10. But then the other M&M can be either yellow, it could be blue, it could be either one. So I'm just going to put a little asterisk here. It could be anything else. How many other M&Ms are there besides red? There's 5 other M&Ms. However, I could either do red. It doesn't say the first one has to be red. It just says 1 red. So I could also do something else, then red. So I need to multiply these fractions times the number of ways to arrange them, which are 2. And this entire thing, I'm going to box it, this entire thing is my answer to party. All right, I hope this did help, and ask questions if you have them.